or be like a noble gas by gaining 1 or 2 or 3 valence electrons, and those become your anions. Okay, all of this talk kind of actually I've bled over into chapter 3 already. Okay, ions in the octet rule. So I just gave a little skew about ions. We know we have. I'm gonna zoom in up here real quick. If we have ions, there are 2 kinds. We can have cations. These have a plus charge overall because they have given away electrons. And we can have anions. These have a negative charge overall because they have gained electrons. These have lost electrons. Okay, they have not lost or gained protons, they've simply lost or gained electrons. Now there's an imbalance between the number of protons and electrons in an atom. Alright, so ions and the octet rule. Don't forget this guy. This was actually a whole short answer question on exam 1, I believe, which says that the tendency of atoms to gain or lose electrons to achieve an octet or a completely filled shell of valence electrons. Alright, so the octet rule allows us to predict what atoms are going to lose electrons, what atoms are going to gain electrons, based on what they need to get a completely filled shell. Now notice we said not necessarily is it always an octet. Sometimes it can just be a completely filled shell. There's a couple of exceptions. Alright, helium, for example, and hydrogen, these main group 1 elements, they can't achieve an octet. Why? Because they only have 1 energy shell. If we draw a picture of their atom, here's the nucleus. They're on row 1, so they only have 1 shell. And this first shell can only hold a maximum of 2 electrons. So the most they can have is 2. They can't get 8. But that's why I said or a completely filled shell of valence electrons. So that's the octet rule. Know it. Know how to use it. Know how to predict the charges on cations and anions because of the octet rule and your understanding of valence electrons. That's pretty straightforward. Most of that stuff you guys have been doing for a long time now. Alright, and then naming ions, polyatomic ions especially, don't forget these, and ionic compounds. Here's some really good problems, okay? 3.6, 3.66, 3.7 in the textbook to give yourself some practice. There's different rules. I'm going to go over these really quick to remind you. For cations, actually, let me back up. If we're naming cations, there's a difference between naming main group cations or elements that become cations and transition metal. Cations. If you're naming a main group cation, here's how you name it. You state the element name, plus the word ion. So for example, you have the potassium, K plus would be the potassium ion. Okay, transition metal cations, you do the element name, you give Roman numerals, okay, to indicate the charge, and then you add the word ion. Okay, so for example, if we had Cu 2+, it would be the copper, Roman numeral 2, ion. And copper is a transition metal, so that's why we would name it that way. For anions, I didn't leave myself a lot of room over here. For anions, the rule is that you just change the ending of the name to IDE. For example, instead of chlorine, that's the element, when you become Cl minus, you call that chloride. Whoops. IDE. Okay? Anions are pretty simple. Same thing with sulfur and oxygen. It'd be sulfide, oxide, fluoride, bromide, so on and so forth. A few more examples. Let's name these ionic compounds. Now let's put the pieces together. Remember, we always write the cation first. So we have a calcium 2+ cation. And then we have the anion second. Okay? This is a typo right here. That 3 should be a 2. Alright. So now we can name this. We have this second, the anion here is a polyatomic. So you just have to, there's no formula for knowing the name, you just have to memorize it. So we would call this calcium nitrate. And remember, when you're putting the cation and anion names together, and because you have an ionic compound, when you name the cation, you drop the word ion. Okay, you don't include it in the name. You just say calcium nitrate. You don't say the calcium ion nitrate. All right, so we drop the word ion from the compound name. All right, so it's calcium nitrate. Okay, if we had magnesium phosphate, so we've got to know that this is a polyatomic, PO4, and the charge with a -3 charge. Magnesium is main group 2, so it's Mg2+. You will have a periodic table, so you should be able to figure that out. Now we got to put these things together. Remember the switch trick. Okay, the charge on my anion is the number of cations I need. So Mg3, because my charge on my anion is a 3. And then I'm going to put in parentheses, anytime you need a polyatomic and you need more than one of them, you got to put in parentheses. So phosphate, if I look at the charge on magnesium, it's 2, so I know I need more than one. That's why I'm putting it in parentheses. So there's magnesium phosphate. Lastly, we have CuCO3. So this again is copper. This is a polyatomic. It's carbonate. And carbonate, because we've memorized it, we know carbonate has a -2 charge. And we have one copper cation. So what's the charge on copper? Well, it's a transition metal. We only have one, and it has to match the charge on carbonate, because these things have to add up to 0. Remember, it always has to add up to 0, the total charge from your cations and anions. So the way we would name this, if we're writing out the name, would be the copper. Remember, it's a transition metal, so we use Roman numerals, 2 carbonate. All right, so we have a +2, we have a -2, that adds up to 0. We have a magnesium. If we go back up here and zoom in, magnesium is a +2. We have 3 of them, so that's times 3, gives us +6. Phosphate is a -3. We have 2 of them, so times 2, that gives us -6. And +6 and -6 add up, oh gosh, sorry, add up to 0. Okay, so on and so forth. That's naming. Lastly, here's kind of just a true-false to check your understanding of chapter 3 stuff. Number 1, true or false? A cation is formed by the addition of 1 or more electrons to an atom. Okay, that is false. Cations are positively charged because they give away. They don't receive. You don't add electrons to cations. You add electrons to anions, or to elements that then they become an anion. Okay, so this one's false. Group 4A elements tend to lose 4 electrons to yield a +4 ion. Group 4 is really the only group we don't talk about very much in chapter 3, okay, because they are more so involved in covalent compounds, so this is false. They don't like to lose that many electrons. That's a lot of electrons to lose. You don't find carbon, okay, or silicon in ionic compounds, really. Okay, elements that form anions are typically found on the left side of the periodic table, and that, if you're looking at a periodic table, the left side would be main groups 1 and 2. That is false as well. The left side of the periodic table is your cations. The far right side by the noble gases are your halogens, and your main group 6, those form anions. Alright, so I think that's it. Here's the table of polyatomic ions. Remember the ones you have to memorize. I'll circle them. Hydronium, okay, H3O. Ammonium, acetate, carbonate. You know what? Why don't I just box these in? All this writing is getting on my nerves. For sure, you have to know these first, like, what, 1, 2, 3, 4, 5. Bicarb is really important, you health majors. Okay, so those first 5, hydroxide is important. You had to know that one. That was 6. I remember there was 11. Nitrate and nitrite. Phosphate. And let's see, that's 6, 7, 8, 9. I believe we did sulfate.